Alright guys, I'm going to go ahead and start with 2.9 weighted average uniform motion part 2. It's pretty much the same kind of concept where you are using the RDT model, which is the distance equal rate times time model. So I'm just going to quickly show you that again, just in case you don't remember. Okay. Distance equals rate times time. Don't forget that whatever the rate is in terms of, like for example, miles per hour, the time will have to stick with the hour. You got to make sure that they have the same units. So with that in mind, let's take a look at this first problem that I have for you right here. It's a distance problem again. And this time you have Jonathan and Omar. One is leaving from Las Vegas to San Jose, and Omar is leaving San Jose to Las Vegas. They are leaving at the same time. Okay, so basically you can kind of draw yourself a figure here. I'm gonna do J for Jonathan and O for Omar. Omar is leaving from San Jose, and Jonathan is leaving from LV, Las Vegas, and they are heading towards, basically they're going the opposite directions. One going to San Jose, one's going to Las Vegas. So if you continue reading, you see that the distance between the two cities is 620 miles apart. Okay, so I'm trying to give you at least a glimpse of what this scenario looks like. You also know that Jonathan's average speed is 8 miles per hour faster than Omar. So that means Jonathan is, since he's going faster, is it true that he's covering more distance? So on this particular diagram right here, you can kind of show that, Jonathan is traveling more, covering more distance than Omar. But 5 hours later, you'll be seeing them passing each other. It means they'll be head to head. Okay, so 5 hours after they start heading, one from Las Vegas, one from San Jose. They will see each other in 5 hours, and at that point in time where you take a snapshot of that picture, you'll see that Jonathan will have covered more distance than Omar. Okay, so let's take a look at that and keep that picture in mind. So this is Jonathan's distance. This is Omar's distance, and the total distance from the two cities should be 620 miles. So what you do want to do is go ahead and set up the table just like before, one for Jonathan. So I'm just going to go ahead and do one for Jonathan and the other one for Omar. Okay, and try to fill in what already given. So we have the rate, we have the time. Rate times time equals to the distance. Okay, RT equal to D. So I'm going to create 3 columns for you to see here. And for Jonathan, let's take a look at his speed. We know he's going 8 miles faster than Omar. And so we need to go back to Omar. Do you know what Omar's speed is? No, we don't. So we can certainly declare him as, hey, I don't know what his speed is. So therefore, I'm just going to go ahead and declare it as X miles per hour. And since Jonathan is going 8 miles faster than he is, it'll be X plus 8, right? Because he's going 8 miles faster. In terms of times, remember, they're going to be passing each other in 5 hours. That means 5 hours after they started heading, in the opposite direction. I mean, heading towards each other, they'll see each other, right? So that the time will be 5 hours in each here. And the D, of course, we just have how to find the D column. You just have to multiply across because distance is rate times time. So it's going to be 5 times x plus 8. And this one's going to be 5 times x. Now, if you refer back to this picture right here, to find the distance, notice that the distance Jonathan cover and the distance that Omar cover will give you a total distance, between the two cities, which is 620 miles. So that should prompt you to add these two together. Because, remember, when we're done, we just focus on the distance column here, and we know that the distance Jonathan covered, which is 5 times the sum of x and 8, plus the distance of Omar, which is 5 times x right here, should give you a total distance of 620 miles, right? If you look at the diagram here, you will make sense out of that. But now all I have to do is just go and start solving for it. And so it's going to be 5 times x plus 40 plus 5 times x equals to 620. Combine like terms, that's going to be 10x plus 40 equals to 620. if you continue solving for it, you will have subtract 40 both sides, of course. That's going to give you 10x equals to 580 divided by 10. X will give you 58. And remember, we declare x to be miles per hour, so that will be our unit. 58 miles per hour, and x is Omar's speed. So if we want to find Jonathan's speed, all we need to do is add 8 to 58. So 58 plus 8. So that's the idea. When you're, of course, this is the scenario that I talked about before, where you are heading towards each other. The distance, when you add them, will be the sum of the distance between two places. Okay, so just kind of keep that model in mind, and I want you to go ahead and try this particular problem on your own. Let's copy this down and work on that. This problem comes from your worksheet, by the way. Okay, so I have another example for you, just another variation to the problem, but I promise you it will be the same type of setup, so it won't be a surprise. Two yellow Lamborghinis leave Milpitas at the same time, one traveling east, the other traveling west. The first Lamborghini travels at 90 miles per hour and the second one at 110 miles per hour. How many hours will they be 400 miles apart? So the first thing that I like you to do is just try to draw up a picture, just to see what's going on. I know that one is going east, one's going west. So to start off, two Lamborghinis, right? So two cars, tails to tails, heading. One's going west, one's going west east right here. One's going west. So they are. So the one that's it doesn't really matter. So let's say the one that's going east is going at 110 miles an hour. So I'm just going to go ahead and label that. And the one going west is going at 90 miles per hour. So this one, it's up to you to decide which one's going faster. I mean, since I didn't specifically tell you which one's going faster, you just decide on your own which one's falling faster. But this one is going east, don't forget, and this one is going west, okay? And my question is, after how many hours will they be? Here's the car now. After a certain number of hours, how long before they are actually 400 miles apart? Okay, so this one is still going at 100 miles an hour, and the other one is going at 90 miles an hour. Okay, so this is the first snapshot, and this is the second snapshot where the two cars are 400 miles apart, and our objective here is to find out how long will that take before these two cars are 400 miles apart. So what we want to do is just set up the same way our car. So this is our Lambo going west, and this one Lambo going east, right? So we got two different Lambo, and we are setting up the DRT. So here's the R, here's the T, equals to D. So let's start finding out the speed of the Lambo going west. It's going at 90 miles an hour, so we're going to put it in there, 90 miles an hour. And the one going east is 110 miles an hour. In terms of times, since we are trying to find the time for both, but remember they are starting at the same time, so that means we can use the same variable for both. So since I'm trying to find that, let's declare x for both. Okay, remember you are a bystander and you are witnessing this event, and so you're taking the time stopper and you're trying to time it yourself, so the time should be the same for both cars. When will it be 40 miles apart? Okay, next up, distance. We know that to find d, we just multiply right across, right? So it's going to be 90 times x, and this is 110 times x. And we also know that this is a distance covered by the Lamborghini going west. This is a distance covered by the Lamborghini going east. If you take the two total distance added together, will be the distance that they are apart, right? So once again, this is very similar to the one we just did. We just go ahead and take the distance of one car, add it to the distance of the other car. Notice we are focusing on distance columns again, and that should give us the 400 miles apart. Okay, so we solve for it. It's going to be 200x equals to 400 divided by 200. x is going to give you 2 hours. So that means 2 hours after they started going apart, they will be 400 miles apart. Okay. So whether that same idea, I'd like you to go ahead and start on this problem. This is also another problem from your worksheets. Take a look at that, finish it up, and we'll discuss this in class.